Hi, my name is Shivali Mohan, and I will be presenting our recent work on developing agents that can handle novelties in open worlds. This work is a joint effort between colleagues at Park and Ben-Gurion University. One of the distinctive qualities of human cognition is its robustness, our ability to function in open worlds, a world that is dynamic, perhaps unknown, and constantly evolving. For example, if you go to India, you'll realize that people drive and walk on the left side of the street. Once you recognize this difference, a novelty, if you will, you can quickly adapt to this new circumstance. However, AI agents are unable to do so, even though they have been demonstrated to have what some would argue superhuman capability in several challenging games. But even very minor perturbations in the environment can cause them to fail. Vidi et al. In a very interesting paper study generalizations in deep RL systems. Amidar is a Pac-Man-like video game in which the player moves on a two-dimensional grid and gets rewarded for traversing each line. They observed that if the test environment is even slightly different, let's look at panel C in this figure. Um, where one of the lines has already been traversed, the agent fails. In general, any model-based or machine-learned system encodes certain assumptions about the environment. These assumptions are either made during modeling or during data collection. When these agents are deployed, these assumptions may not hold, either because they were incorrect or the environment changed. We are studying agent architectures that support robust behavior in an open world by detecting, characterizing, and accommodating for novelty. This research is supported by the DARPA Ceylon program. The approach described in the paper is implemented in the HYDRA architecture. HYDRA is designed for agents that encode compositional, explicit models of the environment that can be used to make predictions about outcomes of actions and processes. Planning agents are an example of such systems that encode expected changes in the environment explicitly. On the top right, there's a notional diagram of the HYDRA architecture. The results reported in the paper are from the cart pole domain, a classical control domain in which the agent is supposed to hold the pole upright by moving the cart left or right. The HYDRA architecture has two main components. The action selection component, the orange box, that is the planning agent written in PDDL Plus to support action reasoning in discrete continuous worlds. It implements continuous processes as shown here in figure 2 that models how positions and velocities of the cart and the pole are updated over time. This is an example of an explicit model of the environment. The novelty reasoning component is shown in the green box. It does two things. First, it computes the difference between what it expects to happen in the environment given its model and its actual observations of the environment. If this difference is drastic and above a predetermined threshold, it flags the existence of novelty. The next step is to explain what's different in the environment and update the domain model itself. The paper introduces model manipulation operators, or MMOs. An MMO changes the PDDR plus model by changing some action, event, or a process. An example is over here at the bottom right of the slide. The action of moving the cart to the left includes a constant, force magnitude, whose value impacts how much force is applied to the cart. HYDRA generates a set of MMOs that either increment or decrement this constant. You can think of these MMOs as various hypotheses HYDRA has about what has changed. MMOs like these define the search space for model changes. HYDRA conducts a greedy best first search to find a sequence of MMOs that minimizes inconsistency while keeping the sequence as short as possible. So how well does HYDRA do? Decently well. Let me go over how to read the graphs first. The columns show different agents that we built for the cart pole domain. A DQ and RL agent, that is the state of art for control problems like cart pole. A planning agent built with PDDL Plus and HYDRA. The rows are different novelties that we evaluated these agents in. The x-axis represents the episodes the agent plays, and the y-axis represents the score it received in that episode. The red line indicates the episode when the novelty was introduced. The blue and the orange lines show agent's performance under two different settings. The blue line is when the agent was not told that novelty has been introduced, and the orange line is agent's performance when it was told that novelty has been introduced. As you can see, all agents are competent at the non-novelty setting, as indicated by the perfect average scores before the red line. Looking at the DQN agent, we can see that it experiences a catastrophic failure. That is, its performance reduces dramatically after novelty is introduced. When it is told that novelty has been introduced, it can learn to act in the new environment, and it takes around 100 episodes to learn a new policy. Both the planning agent and HYDRA are resilient. That is, their performance does not degrade as drastically. This is expected because both of these agents are model based. Some parts of their model still applies in the novelty setting. As expected, the planning agent does not learn. HYDRA does learn and it can quickly recover its performance in around 20 episodes. So HYDRA brings together qualities of planning and learning agents. It is resilient like planning agents, and it adapts with experience like learning agents. And it learns much faster than a DQ and RL learner. Finally, because HYDRA learns by searching over the space of model changes, its learning is inspectable. Its learning is expressed in the same language as the model. So what's next? The paper describes novelty reasoning for simple domains like the card pool. We are extending these ideas to build domain-independent novelty reasoning architecture that supports robust and resilient behavior in complex agents, such as those that can play Angry Birds. Stay tuned.